Can you see the presentation? Is it visible?
Yes, sir.
Thank you. Hello. Good evening, everybody. I am Venkat Subbareddy, a research scholar at University of Hyderabad. So I'm here to teach you the solutions of assignment 1 problem. I think many of you feeling difficulty at the problems 1 and 6. So let me solve those two problems firstly, then we will discuss about the remaining problems. I don't know how many problems we can solve in 1 hour. So let me do those two problems firstly. So let me write the first problem. I'm not writing the whole question. I'm just writing whatever we want. The problem is the value of C for which the system of equations. It is asked to calculate the value of C. The given system of equations is x plus y plus z equal to 1, 3x plus 2y plus z equal plus z equal to 2, 4x plus 3y plus cz equal to 3. So firstly, let me write the system of equations in matrix form. Based on the rank of the matrix A and rank of the augmented matrix AB, we can discuss the number of solutions. So let me write that A equal to the matrix 1 1 1 3 2 1 4 3 C, comma B equal to 1 2 3. Now we will write the augmented matrix AB. This is nothing but combining the two matrices and writing into a single matrix. 1 1 1 1 3 2 1 2 4 3 C 3. So by converting this augmented matrix to echelon form, then we can find the rank of this matrix. Let me call this is row 1, this is row 2, this is row 3. So to convert the matrix AB into row echelon form, firstly we will convert this element into 0, then this element, then this element. We'll make these three elements into zeros, then we can say the matrix AB is in echelon form. So let me do the operations. So firstly we have to make the element 4 here. We have to make this to 0 by using rows R1 and R2. So here I am doing the row operation R3 as R3 minus 4 R1. I'm just making this row first row into this element into 4 times, then subtracting that 4 from here. That is nothing but R3 minus 4 R1. This operation results the matrix. Here the first row and second row will remain the same, 1 1 1 1 3 2 1 2. The third row, it will get changes. The first element will become 0, second element will become 3 minus 4, that is minus 1. Third element will become C minus 4, C minus 4. Fourth element will become 3 minus 4, that is nothing but minus 1. So now again this is R1, this is R2, this is R3. Now we will make the element minus 1. this element as 0 by using row R1. No. Firstly, we will do this element, the element 3. We will make this element as 0 by using row R1. For that, I am doing the row operation R2 minus 3R1. We are converting R2 into R2 minus 3R1. This is nothing but I am just subtracting the element. Let me write it. Let me say it clearly. So I am just doing this times R1 and this first element times R2. I am just multiplying with this and subtracting the operations. That is nothing but R2 minus 3R1. Then the element 3 will become 0. That is the row operation I am doing here. This row operation will make the matrix as the first row will become same, second row will get changed, this will become 0, then 2 minus 3, this is minus 1, 1 minus 3, this is minus 2, 2 minus 3, that means minus 1, and the third row will be same as it is, minus 1. So now again this is R1, this is R2, this is R3. Now we are making this element as 0 by using R2 because these two elements are same. By just adding these two elements we can make this element as 0, this element. Here we are not using R1 because whenever we do operations with R1, this element again will get changed. This will become non-zero again. So we are not doing the operation with R1. We are just doing the operation with R2 only. That is the reason I am using R2 here. So the row operation is R3 plus R2. This will become 1, 1, 1, 1, 0, minus 1, minus 2, minus 1, becomes 0, 0. This is C minus 4 plus 2. That means C minus 2. This is 0 again. The question it is asked so that this system of equations to be consistent. That means it should have at least one solution. It should have exactly one solution. But here, let me write the rank of A and rank of AB firstly, then I'll explain how it is. Rank of
So
A
both are minus 1, no? If you add it becomes minus 2.
where?
Both are minus 1, no? In R2 and R3?
Both are minus 1?
Yeah, I thought so.
No. This is C minus 2.
Yeah, no. 1, 1, 1, 1. 0 minus 1 minus 2 minus 1. Then 0 minus 1, C minus 4. So when we are adding minus 1 after the zeros, both are minus 1. So if you are adding it becomes minus 2, no?
Which one you are saying? These two elements?
The one which the one above which you put in red and the one above that.
This
So
one.
when you are saying R3 plus R2, this is minus 1, this is minus 1.
Yes.
It becomes minus 2, no? How will it become 0?
Sorry. This is R3 minus R2.
Okay.
Yes, you are right. We are just subtracting the rows. So this becomes 0,
Sure.
C minus 4 plus 2C. Yes, now it is correct. Sorry. So here rank of A equal to, here we have two cases. Rank of A equal to 3 if C is not equal to 2, and rank of A is equal to 2 if C is equal to 2. Similarly, rank of AB also. there is equal to same as rank of. So it is asked for consistent, but here we have rank of A equal to 3 whenever C is not equal to 2, but it should be in the question it should be the system of equations should have exactly one solution. Whenever it is asked to have exactly one solution, we will have exactly one solution whenever rank of A equal to rank of AB equal to the order of the matrix A, that is nothing but 3. So if in the case C not equal to 2, it implies the system has exactly one solution. Whenever C is equal to 2, it have exact infinite solutions, infinite number of solutions. Here it is a mistake, but just correct it. It should be the system of equations should have exactly one solution, and the answer should be C is not equal to 2. This is about first question. So nextly we will solve sixth problem. In sixth problem, I heard many of the students are feeling difficulty at the fourth option. They could not. Firstly, let me know how you are solving this problem, by doing the determinant or by doing the by using linear combination equal to 0 and making scalars equal to 0. How you are trying? I'll proceed with that method only so that you can have clarity. Please somebody reply. Which method you are following for the sixth problem? Determinant method or by using linear combination method? That alpha 1, alpha 2, alpha 3, somebody said that. Otherwise, I will do indeterminate method. So let me do the first option. This is, let me write A. So I am writing the set S1 into the matrix form. I am just writing the vectors in column form. 1, 2, 1, 2, 1, 3, 3, 3, 4. By just doing the determinant and checking whether it is 0 or not, we can say the system that set is linearly independent or not. So I am calculating the determinant of this matrix. 1, 2, 3, 2, 1, 3, 1, 3, 4. This is equal to 1 times the determinant of the matrix 1, 3, 3, 4 minus 2 times. I think you know how to calculate the determinant, so I am directly writing the steps. 2, 3, 1, 4 plus 3 times 2, 1, 1, 3. By just doing the elementary operations, we will get this is 4 minus 9, this is minus 5, minus 2 times 8 minus 3, that is 5, 5 into 2, 10, this is minus 10, plus 3 times, this is 6 minus 1, 5, that means 3 times 5, 15. So this is equal to 0. So we can say the set S1 is linearly dependent. Similarly, we will do for the option 2 and 3, 4. Option B is, I'm directly writing the matrix in determinant form so that we can save some time. 1, 1, 0, 1, 3, 2, 4, 9, 5. So the determinant is 1 times 3, 9, 2, 5 minus 1 times 1905 plus 4 times 1302. This is nothing but 15 minus 9, 15 minus 18, that is minus 3 minus 1 times 5 minus 5 plus 4 times 2, that is 8. So this is also equal to 0. So this set is also linearly dependent. S2 is linearly dependent. Option C is 1 1 3 2 3 8. Whatever the given vectors, we have to write the vector into column form. Of course, we can write here while calculating the determinant, we can row in row form also, because the row of the determinant of A equal to determinant of A transpose. But usually the matrices will get changed. So the determinant of this matrix is nothing but 1 times 3 3 8 7 minus 2 times 1 3 3 7 1 3 3 7 plus 1 time 1 3 3 8. This is 21 minus 24 minus 3 minus 2 times 7 minus 9 minus 2, so become plus 4 plus 8 minus 9, this is minus 1. So again this is also 0, so S3 is also linearly dependent. Option 4 is, here I think many of the people are feeling difficulty. The matrix is nothing but 1 1 2 1 2 minus 1 1 3 1 1 times 2 3 minus 1 1 2 3 minus 1 and 1 minus 1 times 1 2 2 minus 1 plus 1 time 1 2 2 minus 1. See, here 1 3 2 minus 1. This is 1 3 2 minus 1. Here 1 time 1 2 2 minus 1. So we'll get 2 plus 3, this is 5 minus 1 minus 6, so minus 7, so it will become plus 7 plus minus 1 minus 4, so it will become minus 5. So this is equal to 7, not equal to 0. Are the calculations correct? 2 plus 3 5 minus 1 minus 6 minus 7, so plus 7 minus 1 minus 4 minus 5, okay, equal to 7, that is not equal to 0. So the set is linearly independent. Can you check the calculations are correct if you have doubt, or you can ask me immediately. So I hope no problem, no doubt in this problem. So let me proceed with question number 2. Given system of equation is x plus y plus z equal to 3z equal to 1, 2x plus 3y minus z equal to 3, 5x plus 7y plus z equal to 7. So it is asked the system of equations. This system of equations, how many solutions does this system have? So again, let me write the system of equation in matrix, augmented matrix form. A, B. I'm directly writing it. 1, 1, 3, 1, 2, 3 minus 1, 3, 5, 7, 1, 7. So I'm doing the, firstly we will convert the matrix into row echelon form. So I'm making these three elements into zeros. Firstly I will do this 5, then 2 and 7. So the operations here I am doing is R1, R2, R3. So to make the element 5 to 5 as 0, I'm using here R1. So I'm doing the operations like this. So what the resulting operation is R3 to R3 minus 5 R1. Here because both the signs of the elements are same, so I'm just subtracting so that the element 5 will become 0. If the signs are different, we can add so that then the element 5 will become 0. That is the difference why I am doing here the subtraction or addition. So the resulting matrix is 1, 1, 3, 1. The first two rows will become same. There will be no change because we are doing the operation to R3 only. So here it will become 0. This is 7, right? 7 minus 5. This is 2. 1 minus 15 minus 14. 7 minus 5. This is again 2. So here R1, R2, R3. Again I am doing the operation. Now we are making the element 2 as 0. So I am doing this to R1 and 1 to R2. Then it will become R2 minus 2R1. It looks not good, so that I am removing that what we are doing here. So the operation is R2 is becoming R2 minus 2R1. So it will become 1, 1, 3, 1. Here it will become 0. 3 minus 2, 1. Minus 1, minus 6. Minus 7. 3 minus 2. This is again 1. R3 will become same. 2. Now we are making this 2 as 0. This element 2 by using R1. I already told you why we are using R1 here to make the element this element 2 as 0 in the first problem. So the operation here is R3 will become, here we are using R2, sorry, R3 minus 2R2, because we already have 0 here, this element, so that this element will not get changed. So we are using the row R2. First row will remain same. Second row is 1, 1 minus 7, 1. This will become 0, 0. Minus 7, minus 14, minus 7, 14 plus 14, 0. 2 plus 2, 2 minus 2, 0. So third row becomes 0 totally. So we can say rank of A equal to rank of B equal to 2, rank of A equal to rank of AB equal to rank of augmented matrix, that is equal to 2, that is not equal to the order of the matrix 3. So it have infinite number of solutions. System. Number of solutions. I think you would know what's the reason, because whenever the rank is 2, it will have infinite number of solutions. I think you would study by the classes. I'm not telling the reason here why it is. So this is about second problem. So third problem is, on applying the elementary row operation R2 given a matrix A, we are applying the row operation R2 to R2 plus 3R1. The resulting matrix is called B, and we have A equal to P inverse B. Then it is asking what is the matrix P. So by the given conditions only we will derive what is the matrix P. So here it is given A equal to P inverse B. From this we can say, so P inverse, it is written P inverse, that means the inverse of matrix P is exist. So we are just multiplying with P on both sides, on left hand side of the above equation. So it will become P inverse B. It is nothing but B. So what we have is PA equal to B. So the operation we are doing here is R2 is becoming R2 plus 3R1. Now you just check the matrix given options. With which option you will get the matrix A into B. So let me write A as R1, R2, R3. R1 is nothing but one vector, one row, one column vector, sorry, one vector. B is the resulting matrix. This is R1. Just R2 is becoming R2 plus 3R1. R3 remains same. So now you check the options with which matrix, whenever we are multiplying P to the matrix A, we will get B. Now we are checking this operation. So the first option is given matrix P equal to, let me call it is P, but we are just checking, so let me not write, otherwise you will get confused. It is given 3 0 0 0 1 0 0 0 1 0 0 1, sorry, 0 1 0 0 0 1 0 1 0 0 0 1. This times A. A is nothing but R1, R2, R3. So what we will get? This is 3 times R1, R2, R3. This is not equal to B. Similarly, we will check the options B, C, D. B is given 1 0 0 0 1 0 0 3 1 into matrix A is R1, R2, R3. This is equal to R1, R2. This will become 3R2 plus R3. But again, this is not equal to B. because we have B is different from this matrix. But whenever we change the based on if we have changed R3 to this 3R2 plus R3, then we can say this is this resulting matrix in the option B as the answer. But here the resulting matrix is not equal to B. That option is 130 010 001. R1, R2, R3. This will become R1 plus 3R2. This is R2, this is R3. Again, this is not equal to B. Option D is 100 311 001. The resulting matrix is this is R1, this is 3R1 plus R2, this is R3. So I think this is the matrix B. What we get? R1, R2 plus 3R1, R3. So option D is the correct option. One zero zero 311. Sorry, this is 0, right? Here also it is 0. Zero zero 1 equal to P. This is third problem. We'll see the fourth problem here. Given a matrix A of order n cross n, the question is about the symmetric and skew symmetric of the matrices A minus A transpose A into A transpose. It is asking which one is symmetric and which one is skew symmetric. I hope you know the definition of symmetric and skew symmetric matrices. So I'll proceed with the solution. So firstly, deal with A minus A transpose. So let me call B equal to A minus A transpose. We will check and C as A into A transpose. C equal to A into A transpose. Now we will check B transpose and C transpose. B transpose is nothing but A minus A transpose whole transpose. This is nothing but A transpose minus A transpose whole transpose. We have A transpose whole transpose is nothing but A. That is, it is nothing but A transpose minus A. So we can write this as minus of A minus A transpose. This is equal to minus B. So from this we can say what we have is B transpose equal to minus B. So B is skew symmetric. That is B equal to A minus A transpose. A minus A transpose is skew symmetric. Now we will see about C. C is nothing but A into A transpose. C transpose equal to A into A transpose whole transpose. I think you might have studied the property. I'm writing inside. We have AB whole transpose equal to B transpose into A transpose. I'm using this property here. So we have what we will get is A transpose whole transpose into A transpose. This is nothing but A into A transpose. So this is equal to C. What we have is C transpose equal to C. So we can say so we have C is symmetric. That is, the matrix C is nothing but A into A transpose. So from the options it is given, the option B, A into A transpose is symmetric, but A minus A transpose is skew symmetric. We'll see the fifth problem here. It is given the matrix A is of order 3 cross 3 and determinant of A is minus 3. B be the matrix obtained by swapping the first two rows of A, then the value of this thing. So let me write the matrix B is, okay, let me write this in the solution, how we are doing it. So let me write A equal to R1, R2, R3, some rows. Then the matrix B is given that it is said B me. Somebody is joining. So B is the matrix obtained by swapping the first two rows of A. That means B is nothing but R2, R1, R3. Now it is asked to calculate the determinant of 2 times B whole transpose equal to what? We have one property that determinant of A equal to determinant of A transpose. From that property we can say we have determinant of 2 times B transpose is nothing but determinant of 2 times B. So now okay. So let me write the matrix as A equal to A, B, C, D, E, F, G, H, I. Then the matrix B from the given condition is D, E, F, A, B, C, G, H, and I. From the given condition that modulus determinant of A is minus 3, that means determinant of A is nothing but here A times EI minus HF minus B times DI minus GF plus C times DH minus EG. So we'll check here what is the determinant of B. Determinant of B is nothing but D times Bi minus CH minus E times Ai minus Cg plus F times AH minus Bg. From these two, can you observe something? Here AEI. So let me tell you what we can observe here is. So determinant, in the determinant of A, we have AEI here. So we have minus of AEI here. And we have minus of AHF here. Here we have plus AHF. So like this we can see from all these terms, determinant of A is nothing but determinant of minus B. That implies determinant of B equal to minus of determinant A. But it is asked to calculate the determinant of 2 times B. If we calculate this, we can find the determinant of 2 times B whole transpose. So from this, since here B is of order 3 cross 3, so we have one formula. Let me write that aside. Determinant of K times K is some scalar here times A is nothing but K power n times determinant of A. Here n is nothing but the order of the matrix A. Similarly, here we have 2 times B. That is, so we will get the determinant of this matrix is 2 cube times determinant of B. So from this we can get 8 times determinant of B. From this we can calculate easily the determinant of the matrix 2 times B whole transpose equal to determinant of 2 times B, that is equal to 8 times determinant of minus 8 times determinant of A, but it is given determinant of A is nothing but 3 minus 3, so we will get this is equal to 24. So option C is the correct. Do you have any doubt in this problem? If you have any, ask me now only. Numbers. I hope you don't have any problem, any doubt here. So let me proceed with the next problem. We already have solved the 6th problem, so I will proceed with the 7th problem. The number of non-zero rows in the echelon form of the matrix. Just converting the matrix into row echelon form, we will get the solution. 1, 2, minus 1, 3, minus 1, 2, minus 1, minus 1. It is 6:44, but people are still joining. 2, 4, 1 minus 3, 1 minus 2, 1, 1, 1 minus 2, 1, 1. If you observe the matrix, we can simply say the rank of this matrix cannot be 4, because if you observe the row 2 and row 4, this R2 and R4, those two rows are just differ by sign. Here we have minus 1, here we have 1, 2, minus 2, minus 1, 1, minus 1, 1. So whenever we add these two rows, we will get the we'll get one row completely as 0. So we can simply say the rank of the matrix A cannot be 4. It should be less than 4. But depending on the other two rows, we can say whether it is 3, 2 or -1, whatever it is. So let me do the operations here. This is R1, this is R3. So I'm making this element as 0 firstly. So by using here, we can use whether R3, R2 or R1. So for simplicity of the calculation, I'm just using R2. I already told you these two rows are just differ by a sign. So by simply adding these two rows, we can make the element 1 as 0. So we are making R4 to R4 plus R2. So the resulting matrix is 1, 2, minus 1, 3, minus 1, 2, minus 1, minus 1, 2, 4, 1, minus 3. Here it will become all zeros. To reduce the calculations or number of steps, you can do both two operations in a single step. Here instead you can do R3 as by using R1. You can do R3 minus 2R1 also in a single step. Then this row also will get changed. But let me do this in another step. While you do calculations, you can do that in a single step. So this is R1, R2, R3, R4. So I'm here doing here R2. Sorry. Now we are making this element 2 as 0. So I'm using R2. I'm doing R3 plus 2R1, R2, because the signs are differ. So I'm just adding the rows and by doing multiplication. 1, 2, minus 1, 3. This is minus 1, 2, minus 1, minus 1. This will become 0, 4, minus 4 plus 2. Sorry, 4 plus 4, 8. 1 minus 2. This is minus 1. This is minus 3, right? Minus 3 minus 2. This is minus 5. Fourth rows are zeros. Fourth row is completely 0. So is it in row echelon form? Still no. R1, R2, R3, R4. The class is almost over, but still people are joining. So now we are making this element as 0 by using R1. By just adding those two rows, we can make the element minus 1 as 0. So we are doing R2 to R2 plus R1. The resulting matrix is 1, 2, minus 1, 3, 0. Plus these people are coming from another class. So this is 2 plus 2, 4, minus 2, 2, 0, 8, minus 1, 5, minus 5, 0. So now you can see the matrix is in row echelon form. Is it? No, still it is non-zero. So we'll make this 0 by using R2. We'll make the element 8 as 0 by using the row R2. R1, R2, R3, R4. So the operation here I'm doing is R3 minus 2R1, 2R2. This is R2 becoming R3 minus 2R2. Sorry, this is R3. So what the matrix is? 1 2 minus 1 3, 0 4 minus 2 2. This will become 0 0 minus 1 plus 4. This is plus 3, minus 5 minus 4 minus 9. These all are zeros. So now the matrix is in row echelon form. From this you can say that what is it is asked, the number of non-zero rows in the echelon form. So this matrix is now in the echelon form. So and the number of non-zero rows are 3, that you can see easily. So number of non-zero rows equal to 3. So let me solve the problem 8 now. This is direct question. Given a equal to 1 minus 2 1 minus 3 3 0 2 2 4. The problem is, if a linear system Ax equal to b is consistent for any b belongs to R, then the rank of augmented matrix. So we can say the rank of the augmented matrix is consistent. It is said Ax equal to b is consistent for every b belongs to R cube. B belongs to R. Sorry, b belongs to R. It should be R cube, right? Okay, let me write whatever it is. This is a direct statement. We can say Ax equal to b is consistent for every b belongs to R whenever rank of AB is equal to 3. Then only the system is consistent. But whenever rank of AB is not equal to 3, that means, let me explain the other possible case. If rank of AB is not equal to 3, that means rank of AB can be equal to 2 or 1. Let me explain the case 2. Whenever rank of AB equal to 2, the other case follows similar. If rank of AB equal to 2, rank of AB equal to 2 for every B belongs to R. We don't know whether rank of A is equal to 3 or 2. So suppose rank of AB equal to 2, but whenever we take the B equal to 1 1 1, we will get the augmented matrix AB as, I'm just writing B, I'm just taking B as 1 1 1, that is some, because I'm just taking this third element as non-zero. We can take 0 0 1 also here, but just for simplicity I'm just taking 1 1 1 all. Then we will get something, since the rank of AB is, no, whenever rank of AB equal to 2, for this B, rank of AB will rank of the matrix AB looks like this. So this will become 0. These are non-zeros. So then rank of AB cannot be equal to 2 for this particular B, but it is given for every B rank of, but it is given for every B belongs to R. I wrote again R cube. It is given for every B belongs to R, but for this particular matrix B, we are getting rank of AB not equal to 2. So this is not a possible case. So we can say rank of AB cannot be equal to 2. Similarly, we can say rank of AB cannot be equal to 1. So rank of AB has to be equal to 3 only. This is how it is. So the answer is B option, that is nothing but 3. Let me solve the 9th problem. This is also a direct question. The given matrix A equal to 2, 1, 3, 1, K, 0, minus 4, 3, minus 1. It is asked the value of K so that A is linearly dependent. So we know we call a matrix A as linearly dependent. The column vectors of the matrix A as linearly dependent whenever determinant of A equal to 0. Determinant of A equal to 0 if and only if column vectors of A are linearly dependent. So we'll just check the determinant of matrix A. Determinant of A equal to 2 times K 0 3 minus 1 minus 1 time 1 0 minus 4 minus 1 plus 3 times 1 K minus 4 3. So this is nothing but 2 times minus K minus this is plus 1 plus 3 times 3 plus 4K. In total this will become 9 plus 1 10. This is here it is 12K minus 2K, so it will become plus 10K. And it is asked the value of K whenever A is linearly dependent. A is linearly dependent, it implies determinant of A equal to 0 if and only if 10K plus 10 equal to 0. From this we can get K equal to minus 1. So option B is the correct. Let me solve the final question. 10th problem. This is also a direct question. It is given rank of A equal to rank of the matrix A over B, augmented matrix, which is less than n, not equal to n, strictly less than n. Then the system Ax equal to B has how many solutions? You might have studied this. Whenever rank of A equal to rank of AB equal to n, there is nothing but the order of A. Here let me write that A is of order n cross n, implies it has exactly one solution. Whenever rank of A equal to rank of augmented matrix AB, both are equal but which is less than n, then it has infinite number of solutions. There is third case also. Whenever rank of A not equal to rank of AB, implies no solution. Here the question is direct about the second statement, about this statement. So from this we can say infinite number of solutions. So the linear system Ax equal to B has infinite number of solutions. So option C is correct. So Ax equal to B has infinite number of solutions.